Radio Joe here with you again. Today in our video we're going to be talking about the N9TAX Slim Jims that we create here at N9TAX Labs. So stick around. This is going to be an amazing look at a very simple, effective antenna solution. Okay, so in this video we're going to take an in-depth look at these incredible little antennas. We're going to look at the gain, we're going to look at the construction of these antennas, and we're going to look at how to deploy them either indoors or outdoors. The first thing we're going to look at is the antenna's gain and pattern. So let's get NEC fired up and take a look at that. Alright, so first I just real quick here, I modeled a standard dipole, wanted to show you that. It's just a vertical 2-meter dipole. You can see the current distribution on it. So very standard, very typical, just center fed standard dipole. So I just wanted to illustrate what the current distribution looked like on that before we look at the Slim Jim and J-pole style antennas. So here we'll look at, this is a plot of the vertical dipole in the elevation plot. So here the center line we're looking at across the middle here is the this would be, you know, right on the horizon, right? So at 0 degrees broadside off the antenna. If you can see down here in the corner, I know it's a little small, it's 2.16 dBi gain. If we go to the other side, very symmetrical antenna, it's also 2.16 dBi. So this is a dipole. This is what a dipole's pattern looks like. So now we'll look at the J-match style antennas. Okay, so here I have just a standard J-pole, and I don't know, it's kind of hard to see what it is, but you see we have the long element here. And we come down around here and we loop back up to form the J. If you look at the top portion of this antenna, you'll see the current distribution here, and this is why I wanted to show you the regular dipole. It's interesting, right? Because what does it look like? It looks, from here up, like the dipole. And that's because that's what it is. This is a dipole. The only difference between a J-match style antenna and a standard dipole is that we're using this transmission line stub here at the bottom to match the impedance of our 50 ohm cable that connects down here to the end of the dipole instead of the center, which is a high impedance connection, right? So this section at the bottom of the antenna, the J-match itself, all it is an impedance transformer. It's not a radiator, and you can see by the fact that only half of the current distribution that is represented up here is shown down here. That is because this is a quarter wave section of feed line. So that's all this is. This is just a impedance transformer at the bottom of the antenna, transforming the impedance to something we could use to feed this at the very end. So real simple. Antenna is basically no different than the center fed dipole, except that we can feed it down at the end, which is a lot more convenient for a vertical type antenna. So now let's look at the plot, because this is where it gets real interesting. Oh boy, what does this look like? This looks like our dipole plot. Isn't that something? So now again, we're looking at the elevation plot along the horizon here at 0. So what is our gain at the horizon? And you'll notice with the J-pole that the highest gain point is actually like right up in here somewhere. Right at the horizon. It's not quite exactly, but man, is it darn close. It's like 0.1 dBi different. So that's really not a big deal. And NEC tells me the gain here of this antenna is now 2.8 dBi. So it's really, what, I don't know, just a little over a half of a dB better of an antenna. Now I do see on the other side here that I'm not quite to the edge. It's 2.52. Still better than a regular dipole. And they will tell you that J-match style antennas do favor one side over the other. So I guess if we are to believe the NEC calculating engine, then they actually do. But a lot of people will argue about what this looks like right here, and will tell you that, You know, oh, a J-pole has negative gain and all this stuff. It's a dipole. It's a dipole. It's going to have very close to dipole gain, and it does. Because what were we? 2.16 dBi, and we're 2.52 on the bad side, and we're 2.8 on the good side. So, a little bit better. Not a ton, but it's basically a dipole. So now let's look at a Slim Jim. All right, so here's a Slim Jim. Basically the same thing. Now we still have our J match down here, which is, we talked about, that's just a impedance transformer. The only difference is we've connected at the top, and we brought another radiator down this side. You can see, again, if you're to believe the Easy NEC calculating engine, that there are now two currents. One is distributed on each of the vertical sections. So there's radiating going on this one, there's radiating going on that one. Now what does that do for us? Let's take a look at the plot. Again, this looks like a standard dipole, right? Same pattern again, right? It hasn't really changed a lot. Maybe a tiny little bit, but again, we're looking at the elevation, this being the horizon right here at 0 degrees. So now if we look at our 0 degree gain, whoa, we're at 3.07. Now there are people out there that will tell you categorically that there is no difference in gain between a Slim Jim and a dipole. And while I would admit that it is not much, it is some. There is definitely a difference between the two antennas. And when you're making them out of twin lead, you've already got the other conductor there. There's no reason not to hook it up and make a Slim Jim out of it, instead of just making a regular J-pole. If you're making it out of copper, copper pipe, maybe it's not worth, squeezing that extra little bit of gain, that you get out of this. But if you're, like I said, if you're making them out of twin lead, there's no reason not to do it. So we go to the other side. The other side, we're 2.8. 2.8 was our J-pole gain. So on the bad side of our Slim Jim is as good as the best side of our J-pole, right? So you see there is a slight bit more gain here. And, well, I don't know. This is it. I don't think the Easy NEC engine lies. Now, again, we don't have an anechoic chamber here at N9TAX Labs, so I can't tell you categorically that this is exactly how the antenna will radiate. However, this is a very trusted piece of software that people have used for many, many years, and this is a very simple antenna to model in it. And my gut tells me this isn't wrong. Especially from what I've seen as far as the performance out of the antennas. So hopefully this dispels any myths that propagate online and things like that. One, that this is, some amazing 7, 8, 10 dBi gain antenna, or, God forbid, a 7, 8, 10 dBd gain antenna, which would be ridiculous. But that it is what it is. It's a dipole, and a dipole is a great antenna. They're the basis for almost every antenna made. So, again, hopefully this dispels any myths and gets everybody on the same page as to what these antennas are and how they work. So while we have Easy NEC open, let's take a look at one more thing. This is the three-dimensional plot of the Slim Jim antenna pattern. And it shows us a lot of things here, right? A lot of people ask me, well, does the antenna have to be mounted vertical, or can it be mounted horizontal? So there's a number of different problems with not mounting an antenna vertically when you're doing FM type work. One, most of the other antennas you're talking to are going to be mounted vertically, right? So you want your electrical pattern to be vertically polarized like the other antennas, or you will actually get loss against the other antenna. But beyond that, if you look at this pattern, it looks like a big donut, right? So when we look down on the antenna from the top, we see it's very nice and symmetrical. So it's radiating energy in all 360 degrees almost equally. No antenna is perfectly equal, but it's very, very, very close. So our chances of talking to somebody over here or talking to somebody over here are just as great if we're mounting this vertically. If you look along the horizon, that is your highest point of gain. So you definitely always want to mount them vertical. And it's nice to look at something like this. So I just wanted to show you this before we move on in the video, because it helps me to visualize. So it's probably a really good thing to take a look at. Okay, so real quick here, we're just going to take a look at the construction of the antennas. So starting at the bottom, this is our standard antenna. It just has a very short piece of cable on it to facilitate a connector, our ferrite decoupling bead, and the connection to the bottom of the antenna. Here where we connect at the bottom, we do have a little zip tie here. Acts as a strain relief, keeps the cable from pulling on the heat shrink and ripping it apart, especially in wind and things like that. It's very important that this is here. So it's one of the points you might want to inspect if you have them outside, and you check them periodically to make sure that zip tie is still in good shape. All the heat shrink that we use on these antennas is all adhesive type heat shrink to seal this from the weather. Still another thing, if you do have these outside for long periods of time, you want to check, make sure nothing's come delaminated. It can be heated back up and pushed back down if it were to ever delaminate, which I don't have a big problem with, but it's nice to know that you can do that if you have to. So at the very bottom of the antenna, and this goes for all J-match style antennas, is you'll have the stub, the tuning stub here. This is what allows you to match the impedance at the end of the antenna, which is a very high impedance since we're feeding it at the end, to the 50 ohm impedance that our feed line has. So the way this works is it's shorted at the bottom. It's a quarter wavelength stub. So where it's shorted, it'll be 0 ohms. And as you move towards the other end of the quarter wavelength stub, you will move to a very high impedance point. Well, the impedance is gradually increasing along this stub. So way down here at the bottom where we tie our cable into it is where it's 50 ohms. At the top here, it's in the thousands of ohms, which matches the end of the antenna. So very important part of the antenna, does not radiate any energy too. That's important to know, because a lot of people ask, if they have short attics or things like that they need to put the antennas in. You can actually run the matching section at a 90-degree angle to the antenna itself without causing any pattern disruption, since this doesn't transmit anything. So it's a nice to know feature there. As we move up the antenna, we pass the notch here, and you see in the middle here we have our stubs. This is a dual band antenna, so what these stubs do is allow us to electrically cut the antenna off at this point here and make this our UHF radiator. Okay, and these work essentially the same way that the matching section works. They're shorted at the top and they're open at the bottom. So and they're cut at a quarter wavelength to the center of the UHF band. So what happens here is it creates a very high impedance point at this end of that stub, electrically stopping the wave from traveling any farther up the antenna. So what that does is it cuts it off right here, which is our half wave radiator at UHF. Now the rest of the antenna, the VHF portion doesn't see this because it's a quarter wave stub at UHF, not at VHF, so it doesn't look like anything but a piece of wire to the VHF wave, which the rest of the antenna is the rest of the VHF section. So at the very top here is our last feature. We have a little hole punched so you can hang this. Obviously, if you're using some ropes that are too big, out in a tree or something like that, you can go through one of the windows. I wouldn't tie it on the wire on the very end because this is just soldered, and stress over time could break that solder joint. So that's something we want to keep an eye on, not stressing out. So definitely go through the windows if you're going to use a rope. Now, this is something new we're working on here. We're going to start offering these on the site. It's a little hook. It's made large so that it can hook around curtain rods and tree limbs and things like that. It has this little ball here on the end of it, and the way this works is you will take this little ball and pop it through the hole on the end of the antenna. Creates a nice sturdy connection there and will allow you to hang the antenna on things. This is all plastic. It's made in a 3D printer, so it will keep the antenna isolated from whatever you're hanging it from. So look for that on the website. New product will be available here very shortly, if not already, when this video comes out. So, all right, so in this next section of the video, I'd like to talk about mounting the antennas. Specifically in this section, we're going to talk about mounting the antennas indoors. I get a lot of questions about mounting these things indoors, and yes, you can use them indoors. There are a few caveats to consider when you're using them indoors. One, antennas in general, not just this antenna specifically, but antennas in general, when things touch them or touch their radiators that weren't considered to be part of the antenna originally, it does change the velocity factor of the wire. So it changes the amount of speed that the wave moves through the wire. And why is that important? Because the speed that the wave moves through the wire has to do with the tune of the antenna. If you make it slower, the antenna is going to feel longer and its tune is going to move lower in frequency. So I get a lot of people who will buy these and will just tack them up against the wall. They may seem to work okay, but then one day they get a SWR meter or nano VNA or something like that, and they go to measure this antenna and they say, oh, the SWR is terrible. What'd you send me, a piece of junk? No. We tune these in free space. So, which is we hang them up, nothing but air around them. And that's really how an antenna needs to be mounted. Now, it doesn't need to be like out in the middle of the yard. A couple inches away from a solid piece of material will be fine to keep it from detuning. You also probably want to keep it about a foot from any metal, as metal will distort the pattern of the antenna. Generally, the more free and clear you can put any antenna in space, the better it's going to operate as far as its pattern and not being distorted and also not being detuned. So that's even important when you're like hanging this on something. We do put a little hole in the end of the antenna, as I showed earlier. New product that we're coming up with here, this should be listed on the site at or around the same time that you see this video. We did show this in the construction portion of this video, but I'm going to show you again. So we have this hook. It will snap into the hole at the end of the antenna and allow you to hang this thing up, probably a lot more easier than using like a zip tie or anything like that. So check these out. They will be available very soon on the site. If you're not using that, you can use string, rope, anything basically that's non-metallic. I wouldn't want to use like a paper clip or a coat hanger or something that has metal in it, because again, getting metal close to the conductors will have that detuning effect on the antenna. So very important. The best place to hang these things up is in a window. Windows are pretty transparent to RF generally. Some of the newer low E glass can be a little bit of an RF blocker, but generally windows are about the best place of egress for RF into your home. So hanging this in a window, especially a tall window if you have one, again, don't worry about if the matching section is hanging below the aperture of the window, because it doesn't radiate. It can hang past the bottom of the window, won't bother a thing. So putting this in a window is the best thing. Now, the thing to think about when you think about hanging an antenna inside of a home is the way that RF enters a home, because RF behaves almost identically to the way light behaves. So think about the sun in the afternoon when it comes barreling through that window and you have these light beams that cast themselves into your home. Now there is this one small section along those light beams where it is very bright. RF is going to come into your home the same way. It's going to come in beams. It's going to bounce off of things. Some frequencies bounce better than others. Some frequencies get absorbed better than others. So that your mileage will vary on that. But thinking about how RF enters the home, there's places inside of my house right here where I can hang the antenna right here, not specifically here, but somewhere in the house, and I get perfect full quieting signals on all the local repeaters and do pretty good on simplex. When I move this thing 1.5 feet to the left, it's dead as a doornail. So you have to be very careful when deploying them indoors. It's going to take some experimentation, and it should take some experimentation, because you want to find that sweet spot in your house where this is going to work. The biggest value of putting an antenna on this, beyond the fact that it is a full-size half-wave antenna as compared to possibly the rubber ducky antenna on your portable that isn't very efficient, is the fact that you can put this in an optimal place and then run cable to wherever you're going to operate your radio. That is the biggest benefit of an antenna like this when using it indoors. So definitely go around, do the studies, figure out where the best place is. You're going to have a much better experience from your radio and from your antenna. So one of the last things I want to talk about when we're talking about indoor mounting is attics. I get a lot of questions about attics, and we did talk about this very briefly when we were looking at the construction of the antenna, but here at the notch, where the connection between the impedance transformer and the actual radiator of the antenna itself, there's no reason this can't be bent at a 90-degree angle. This shortens the antenna by a quarter wave, which is basically a third of the length of the antenna. So if you have a short attic and you want to put this antenna up in the attic, and I think you should if you're going to put it inside, and you can, because higher is normally always better with an antenna, you can bend the bottom of this thing at a 90-degree angle. Again, try to keep this from touching anything. So I would hang it up and then support this somehow, but this will buy you some extra length, and it varies a little bit on the bands of the antenna, but this will buy you taking 1/3 of the length off of the antenna to get it into a tight attic space. So that can be important too if that's where you're trying to mount the antenna. All right, so for the last section of the video here, we're going to talk about outdoor mounting of the antennas. I was hoping to do this section outside, but we're in northern Indiana. As soon as northern Indiana heard that it was spring, it decided to snow and the weather got really bad. So there's no reason why I can't explain this just right here. This is some pretty simple concepts that we're going to look at on mounting these antennas. So ideally, you would put an antenna, whatever kind of antenna it was, as high as you could. And I know a lot of people don't have towers and things like that to get antennas up high, but many people have trees. Trees are a really good way to get these antennas up in the air. They're really simple. I use a 3/16 Dacron cord that you can buy on Amazon, or you can buy at various different RF DX engineering places like that. All carry Dacron rope like that. I would definitely suggest the black Dacron rope. It's UV stabilized. It's going to last you a lot longer outside than some other kinds of ropes will. And trust me, I've tried cheap stuff and I've tried good stuff. The Dacron, it lasts me years. So a good rope like that, a 3/16 is about a 700-pound test rope. Nothing you hang from that is going to be 700 pounds, and the thing's going to last you a long time. It's very thin, it's hard to see, so it's a stealthy installation. You can check out one of my other videos where we did talk about building a tennis ball launcher that allows you to fire the ropes over the trees. I'll tell you, for years, I used a slingshot with a little metal nut tied to a fishing line to get the antennas over the trees, and while it was effective, wow, is that tennis ball launcher better. I mean, if I would have known that thing was that good, I would have made one 20 years ago, because I fussed around a lot getting antennas into trees, and that thing is just no fuss, no muss. I helped a friend put an antenna up the other day, and literally it was one shot, one tree each time. We didn't have to try it a second time. The ropes went right where we wanted them. That antenna was up in less than an hour. It was amazing, and that was a big HF wire antenna. So 2 trees were involved. It was an amazing tool. So definitely consider something like that if you're going to put it in trees. You can build them yourself. There are some people who are selling them online. I've seen them at Hamfest for sale. Can't say enough good things about them. Not trying to make any money off of myself, just trying to save you a little bit of headache. So anyway, regardless of how you get your rope up into the tree, whether you tie it to a rock and throw it over a limb or anything like that, the important things to consider when tying it to the antenna is you want a good solid connection to the antenna. If you have a rope that's small enough to get through the hole, and we have started punching a little bit larger holes in these antennas than we used to accommodate a little bit bigger ropes. If your rope is too big to go through there, you can always put it through a window. Again, I know we mentioned this earlier, but I can't say it enough times. Don't tie it through the little wire at the top. That can damage that wire. We want to keep that nice. Cable. You don't want cable hanging off of the bottom of the antenna. And it's not that the antenna itself couldn't handle it, but the connectors that are put on the cable at the bottom of the antenna are not designed to hold weight. I learned this the hard way years ago when I had an antenna that was up in a tree, and the cable pulled the connector off the end of the cable, or the main cable hanging up in the tree. It was heavy. It was some LMR 400 cable. Pulled the connector off the end of the antenna. I had a heck of a time getting that antenna out of the tree, because now I didn't have any weight for it to come back down when I lowered my rope. It had to be pulled over in the path of the rope, which it got stuck. Trust me, you don't want to break the connector off your cable for a number of reasons. So if you do hang an antenna up in a tree and it's not just light a little tiny bit of cable at the bottom, you definitely want to support the cable also. You tie your rope at the top, just let your rope trail down the antenna, tie it to the cable as well. Very important. It will make sure that there is no stress on the antenna itself. And you only have to take a little bit of weight off of it, just enough so it's not stressing the connector. Everything still stays nice and straight. The rope running along the antenna isn't going to bother anything. So it's a really good situation. The other thing I get asked a lot by people is, can I put this antenna inside a PVC, tape it to PVC, the whole 9 yards? I've never found a good way to do that. These antennas can be compensated for to go inside of PVC. The problem is I will go to 5 different home centers and buy 5 different brands of PVC, and they all change the antenna a little bit differently. So unless I were to ship you the specific piece of PVC the antenna was cut for, the odds are you couldn't find one exactly the same that wasn't going to mess your antenna up. So I try to stay away from that. I do have a solution for people who want to rigid mount the antennas that doesn't use PVC. And that is these ATV flag masts. Okay, I don't know how well you can see this here. It's really tall. It has the whole antenna on it. But right now we're looking at the backside, and all these are is a 1/4 inch fiberglass rod. The one that I have here in particular is a 2-piece, so it does have a metal collet here in the middle. You can pull it apart and it allows it to not be so long. So if you do have to put it in a car or something like that, it's handy maybe to get these 2-piece ones, and I only paid like $10 for this. This was amazingly inexpensive. They might be a little bit more nowadays. I bought this thing like a decade ago. But so if you do get the one with the piece of metal, pooch the antenna out a little bit there so it's not resting against the metal. Now, because of the way we attach this to the ladder line here, and basically what I do is I take just a paper hole punch. You should be able to find one at your local home center or at a drugstore or something like that. Just a regular paper hole punch will punch holes in the webbing in this cable. And I punch pairs of holes, as you can see that there, right? And put a zip tie through the hole pair and around the fiberglass rod. And what that does is it keeps that fiberglass rod right in the center of that antenna. So that's the farthest away from the conductors that it can be, right? And that's important because it helps to minimize the amount of detuning that this thing does. Now, these fiberglass rods, I mean, they're made to go on ATVs, so you know they will bend quite a bit. They're very strong. Definitely stand up really well in the wind. Keep the antenna holding up. They're very convenient to mount as well. Now this is my demo model here, and all I've done, they have a bolt affixed to the bottom, so it's basically a bolt with a hole drilled in it, and the rod is epoxied into that bolt. And all I did was take this piece of metal and I threaded a hole in it and just screwed that bolt into it, so I could just kind of stand this thing up anywhere. You know, if you had, say you lived in an apartment, you know, you can stand this thing up like out on your little patio outside the sliding door, and boom, you have an antenna. And you know, if people complain about it, you could just take it in at night, or you know, only put it out when you're using it. So lots of different ways to use these fiberglass masts to mount these antennas. Very handy. This is the N9TAX Labs approved method of vertically mounting this antenna without an overhead support. So not hanging it, right? You want it to support itself. And I understand, you know, you can buy fiberglass antennas. They're hundreds and hundreds of dollars. I understand that people not wanting to spend that kind of money when you can spend $30, purchase a Slim Jim, put it on something like this. And I'm telling you, use the fiberglass masts. They're the best way to do that. The bolt on the bottom with a nut, it can screw into almost anything. So it's very versatile to get mounted. You can buy, you know, chimney antenna brackets and things like that. Anything that you can come up with, a little angle iron or something, you can get that thing mounted. Okay, so the final thing I want to talk about, and I looked around to see if I could find any silicone tape. And I don't know quite where mine is just right now, but any connectors that you have exposed out in the weather outside, you definitely want to tape them up properly so that you don't have water intrusion. No connector should be left outside. I don't care what kind of connector it is. without being sealed properly from the weather. And there are very few connectors that are made that I would trust to leave out in the weather without tape on them. And the ones that there are very expensive. Not worth it for this type of application. So, home centers, you can buy silicone tape, usually in the plumbing section. Sometimes it's called like rescue tape or repair tape. It can be used to tape up like hoses and things like that. It's very watertight. If you stretch it and wrap it around well enough, it works really well. It comes off real nice too. Doesn't leave any residue on your connectors. That's a big important thing for me, because there are other materials available like butyl rubber that are a real mess to try and remove from the connector later. So the silicone tape is good. Butyl rubber is great. You put that stuff on there, you're never going to have any water ingress into that connector. But the silicone tape, a nice evenly wrapped layer of that, then put a regular electrical tape over top of it, and that connection, I did that to some of my antennas outside, and lasted a decade. And before the antennas fell down because whatever was supporting them died, like a limb or something like that, and the connections were still fine. So but again, very important, just something that I wanted to point out. If you're doing an outdoor mount, you definitely want to seal up that connector, and shouldn't have any problems. The antennas themselves outside, as is, I would consider to be waterproof minus the connector. We've tested, even with the exposed ends that aren't sealed up, for water ingress down into the cable. So, had them outside for 4 or 5 years, cut them apart. That copper is still shiny as a new penny. And to me, that says that water's not wicking into that. It's a solid conductor. It has polyethylene around it, so it's not getting down into everything else that has access is sealed with the heat shrink. Should keep the water out. If you live somewhere, and I know some people are concerned, like live on the coast near salt water, things like that, where they're worried about corrosion, especially even with the copper, a little bit of liquid electrical tape, you can seal the ends up if you'd like to. Won't hurt the antenna. So that's it for outdoor mounting. All right, well, hopefully you enjoyed our video today. Glad we got to get some of this information out there. I know it's been a long time coming with these antennas. And again, as always, if you enjoy our videos and you'd like to see more of this, please hit that like and subscribe buttons down there. We certainly appreciate your support, and we'll see you in the next video.